So, after the end of this lecture, you would be able to understand a rapid sand filter of the topic gravity filters. Let's start. So, now we have a rapid sand filter. Rapid sand filtration is the most common type of filtration used in water treatment. Here we have the picture of rapid sand filter. It is a technique common in developed countries for treating large quantities of drinking water. It is a relatively sophisticated process, usually requiring power operated pumps for backwashing or cleaning of the filter bed and flow control of the filter outlet. A continuously operating filter will usually require backwashing about every 2 days when raw water of relatively low turbidity is used. The rapid sand filter utilizes the removal mechanisms like straining, settling or sedimentation, and adsorption. The rapid sand filter, the rate of filtration of rapid sand filter have large capacity, that is of 3000 to 6000 liter per hour per square meter of filter area. Because of the higher filtration rates, the aerial requirement of a rapid filtration plant is about 20% of that required for the slow sand filter. Now we have the components of rapid sand filter. So in the components of rapid sand filter, first we have enclosure tank. It is an open watertight rectangular tank constructed of stone or brick masonry or concrete as shown in this picture. The depth of the tank is about 2.5 to 3.5 meter. The surface area of the tank may vary from 10 to 50 square meter. Thus, depending on the total surface area of filter required, a number of small filter units are provided. These filter units are arranged in series. Further, for flexibility of operation, a minimum of 4 filter units should be provided for larger water treatment plants and a minimum of 2 filter units should be provided for smaller water treatment plants. And the next components we have filter media. The filter media generally consists of a sand layer as shown in this picture. It is sand layer or a sand bed of thickness 60 to 75 centimeter. The effective size of the sand varies from 0.45 to 0.70 mm. The uniformity coefficient of sand varies from 1.3 to 1.7 mm. The common value we can take 1.5. Due to higher value of effective size and lower value of uniformity coefficient, the void space in the filter media is increased, which result in a higher rate of filtration for this filter. The next components we have base material. The sand layer is supported on base material, that is a layer of gravels which consists of 45 to 60 centimeter thickness. The gravel bed is graded and it is laid in the layers. The topmost layer should be of a small size gravel and the bottommost layer should be of big size gravel. And now next components we have under drainage system. Here we have the plan of under drainage system. In the case of a rapid sand filter, the under drainage system serves two purposes. Firstly, it collects the filtered water uniformly over the area of the gravel bed. Secondly, it provides uniform distribution of backwash water without disturbing or upsetting the gravel bed and filter media. In rapid sand filter, we have additional components. So we are going to learn about these additional components of a rapid sand filter. So first we have wash water troughs. Wash water troughs are provided in the upper portion of the filter tank. Here we have the picture of wash water troughs. It collects the backwash water as it emerges from the sand and to conduct it to the wash water drain. These troughs may be constructed of RCC, asbestos cement, plastic, cast iron, and steel, out of which RCC troughs are commonly used. The point to be noted, the spacing of the troughs from the layer of the sand is kept between 1.2 to 2 meter so that the horizontal distance traveled by the dirty water over the surface of the sand bed is kept between 0.6 to 1 meter before entering the trough. In this, next we have air compressor. During backwashing of filter, the agitation of the sand grains is carried out either by water jet or by compressed air. When compressed air is used, then we are using air compressor of required capacity. Here we have the picture of air compressor. Generally, it should have the capacity of supplying compressed air at the rate of 0.60 to 0.80 cubic meter per minute per square meter of filter area for 5 minutes. The pressure of the compressed air should be sufficient to overcome the frictional resistance offered by the air pipes and the depth of water lying above the air distribution system. In this, next we have rate control device. It is essential to maintain a constant rate of filtration irrespective of loss head through the filter. So, here we have rate control device. The rate control device is important because a sudden increase in the rate of filtration may cause water to break through the filter material without proper treatment, and a certain reduction in the rate of filtration may release a bubble of gas retained in the sand, causing it to make a hole through the filter bed. In order to automatically control the rate of filtration, the most commonly used device is simplex rate controller. In rapid sand filter, we also have other various accessories such as head loss indicators, meters for measuring the flow rates, etc. So, now we are going to assemble these components of a rapid sand filter. Here we have assembling of a rapid sand filter. When we assemble these components, then firstly we'll have enclosed tank with concrete base with inlet and outlet arrangements. So for inlet arrangements, we have an inlet chamber with the inlet valves and pipelines is constructed for admitting the effluent water from the sedimentation tank without disturbing the sand layers of the filter media and to distribute it uniformly over the filter bed. After that we have filter media, that is a layer of sand, or we called it sand bed of thickness 60 to 75 centimeter. After that the sand layer is supported with the base material, that is a layer of gravels, or call it gravels bed of thickness 45 to 60 centimeter. So now for outlet arrangements, we have main drain pipeline connected with the laterals and strainers constructed below base materials for gravel beds for collecting the filtered water from through the pipelines, and the another side of the main under drain line is connected with the wash water storage tank for the purpose of backwash of the filter to remove the blockage of the filter. For the purpose of backwash, air compressor is connected to provide air during the process of backwashing of the filter. And to collect the dirty water after backwash, a pipeline is connected to wash water gutter, and drain water pipeline and valves are connected to drain the water from the filter after the backwash process. In this sand filter, the additional apparatus installed for different purposes such as filter rate controller and head loss indicator to monitor the rate of filtration of the rapid sand filter. So, now before proceeding to the operation of rapid sand filter, we are going to learn more about the design of the under drainage system of rapid sand filter. Under drainage system of rapid sand filter serves to support the filter medium and gravel to collect filtered water evenly from the bottom of the filter and to distribute air and water evenly across the bottom of the filter during backwashing. Key to this function is the evenness of filtration and the distribution of backwash air and water. They are consist of two types. One is perforated pipe system and another one is pipe and strainer system. So, in this first we have here perforated pipe system. For the perforated pipe system, here we have plan of under drain system whose breadth is 8.9 meter and length is 11.1 meter. In this system, there is a central drain or manifold to which a number of lateral drains are attached on either side. The central drain as well as lateral drains are usually made of cast iron, but these may also be made of other materials such as plastic, asbestos, cement, concrete, etc. The lateral drains are placed at a spacing of 15 to 30 cm. The lateral drains are perforated pipes. So, you may think what is this perforated pipe is? So, here we have the picture of perforated lateral pipe. Perforated pipe is designed in such a way that it allows water to enter or exist through a number of small holes along the pipe as shown in this picture. So these holes are made, that is, these perforation on the bottom side which make an angle of 30 degree with the vertical as shown in this figure. The diameter of the perforation varies from 5 to 12 mm and these are staggered. The spacing of the perforations along the laterals may vary from 80 mm for perforation of 5 mm diameter and for 200 mm for perforation of 12 mm diameter. So in this we have another types, that is pipe and strainer system. In this system also we have central drain or manifold with lateral drains attached to it on either side. In this system, holes are drilled at the top of the laterals and each hole is provided with strainers. A strainer is a small pipe of brass which is closed at top and contains holes on its surface. The strainers are either screwed or fixed on the top of the laterals. There are various forms of strainers devised by different manufacturers of filter units. Some strainers are of umbrella shaped strainers. As you can see in this picture, these strainers have a special air orifice and are employed where an auxiliary air wash is used. The lateral drains as well as the strainers are generally placed at a spacing of 15 to 30 cm. All the strainers are usually placed at the same elevation. The point to be noted, when pipe and strainer system is adapted, compressed air is used for the purpose of backwashing of the filter. This results in saving of wash water, thus it requires about 250 liters of water per minute per square meter of filter area for the purpose of backwashing of filter. This is known as low velocity wash, whereas the perforated pipe system is known as high velocity wash, which is required about 700 liters per minute per square meter of filter area. The water for backwashing is obtained from a wash water overhead tank. So, now we have operations of rapid sand filter. For the operations of rapid sand filter, here we have the structure of rapid sand filter. In this, we have different valves for different operations. So first of all, we'll have an overview on these valves. First we have valve number 1, that is for the purpose of admitting the inlet water from the sedimentation tank. Next we have valve number 4 is allowing the filtered water to the storage tank, whereas valve number 2 and valve number 3 is for drain purpose, and valve number 5 is for air supply from the air compressor unit, and the valve number 6 is for water supply during the backwash process from the wash water storage tank. So for the operation of the sand, first of all, we need to close the valve number 2, 3, 5 and 6. After that, we'll open the valve number 1 and 4. And from the valve number 1, water gets into the filter coming from the sedimentation tank and moves to the inlet chamber. With the help of gravity force, it passes through the filter medium, that is granular sand, and after that filter water moves to the lateral drains passing through the layers of gravels, and from these laterals waters are collected into the central drains, which further moves for the storage following disinfection process. So now we have the cleaning process of the rapid sand filter. For cleaning the rapid sand filter, we have to perform backwash process. In this backwashing process, the flow of water through the filter is reversed to cleaning out the trapped particles. The question is, when to backwash the system? The three factors can be used to assess when the filter needs backwash. Some plant uses the length of the filter run, arbitrarily scheduling backwashing after 22 hours, after 72 hours or some other length of filter operation. Other plants monitor turbidity of the effluent water, and some are determined by the head loss within the filter to determine when the filter is clogged enough to need cleaning. So the head loss is a loss of pressure, also known as head, by water flowing through the filter. When water flows through a clogged filter, friction causes the water to lose energy, so that the water leaving the filter is under less pressure than the water entering the filter. Head loss is displayed on the head loss gauge. Once the head loss within the filter has reached between 1.5 to 2.5 mm, a filter should be backwashed. So now we have backwashing of rapid sand filter, and here we have the structure of rapid sand filter and the arrangements of different valves. During the operations of the rapid sand filter, we have valve number 1 and valve number 4 in open position, and valve number 2, 3, 5 and 6 in closed position. So when we are going to do the backwashing, at the time of backwashing, we have to stop the operation. For that, we have to close the valve 1 and 4, and for the backwashing, we have to open the valve number 5, and air is blown back through a compressed air unit for about 2 to 3 minutes at a pressure of 20 to 35 kN per square meter. Following these, valves number 2 and valve number 6 are opened, and upward flow of water is sent through the bed at a carefully designed high velocity. This should be sufficient to expand the bed 20 to 50% and cause the sand grain to be agitated so that deposits are washed off them, but not so high that the sand grains are carried away in the rising upward flush of water. During the backwash process, water flow above the filter as shown in this picture, and water moves to the wash water gutter. After the washing of the filters has been completed, then we need to close the valve number 5 following valves number 2 and 6. Once backwashing completed, we need to rinsing the rapid sand filter. So for rinsing the rapid sand filter, we need to open the valve number 1 and 3. This restores the inlet supplied through the valve number 1. The filtered water is wasted to the gutter for a few minutes after this until the required quality of water is achieved. Ultimately, the valve number 3 is closed and 4 number is opened to get the filter water again. The entire process of backwashing the filters and restarting the supplies take about 15 minutes. The specified minimum backwash time for a rapid sand filter is 5 minutes. The amount of water required to wash a rapid sand filter may vary from 3 to 6% of the total amount of water filtered. Upward wash rates are usually of the order of 0.3 to 1 meter per minute. Alright, so now you have understood the rapid sand filter of the topic gravity filters. Hope you enjoyed the lecture. See you again in the next one.